May 2011, Core 1, Question 4. I'm going to start by differentiating to find the gradient function. So we have dy dx. 2 times 4 is going to give me 8x, minus 2 times 3, 6x squared, and minus 1 differentiates to give 0. When x equals 2, the gradient of the tangent will be 8 times 2 minus 6 times 4. So it's 16, take away 24, which is minus 8. Gradient of the normal times the gradient of the tangent is minus 1. So if we have a gradient of tangent of minus 8, gradient of the normal will be the reciprocal and change the sign, so that's 1/8. To be able to find the equation of a straight line, I also need to have a y value. So if x equals 2, y equals 4x squared minus 2x cubed minus 1. So that's 16, take away 16, take away 1, which is minus 1. Gradient is 1/8, x is 2, y is minus 1. Y minus y1 equals m upon x minus x1. So y plus 1 equals 1/8 upon x minus 2. I'm going to multiply across by 8. 8y plus 8 equals x minus 2. 8y minus x plus 10 is equal to 0. Part B. We're asked to show, and we should always remember that show is equivalent to prove. So if y equals 8 root x, that's 8x to the power 1/2. dy dx would be 1/2 times 8x to the power minus 1/2. So that's 4x to the power minus 1/2. And d2y dx squared would be 4 times minus 1/2 x to the power minus 3 over 2. So that's minus 2x to the power minus 3 over 2. Gathering together all the information I have been asked to show that this equation is equal to 0. So I'm going to substitute in my values. dy dx is 4x to the power minus 1/2, and we want that squared, plus y, which is 8x to the power 1/2, times d2y dx squared, so that's minus 2x to the power minus 3 over 2. 4 squared is 16, and x to the power minus 1/2 squared is x to the power minus 1. 8 times 2 is 16, so we have minus 16, and then we have x to the power 1/2 times x to the power minus 3 over 2, which tells me to add the powers. So I have 16x to the power minus 1 minus 16x to the power minus 1, which is 0. So we've shown that that is equal to 0, the right hand side.